Okay. Good evening and very welcome to this relatively late site event in the International Cryosphere Climate Pavilion. I would like to thank the organizers for inviting us here today to have an interdisciplinary conversation about international law's response to sea level rise. I will introduce our two speakers and then maybe say a few words about why I think this is such an important event. And I'm really grateful for everyone who is watching this. Today, it is quite late for us here, though. We had an eventful day already, and some of us only arrived yesterday quite early in the morning, I should say. But nevertheless, I'm looking forward to the next 45 minutes, perhaps also, where we are going to talk about how we can bring the science on sea level rise in glaciology and international law into one, because they're still quite far apart often. Now, the speakers today are Chris Stokes, professor in geography and glaciologist from Durham University, and also Dr. Niloufar Oran, who's the director of the Center for International Law at the National University of Singapore, and also the co-chair of the UN IOC Working Group on Sea Level Rise. So she will say a few words about the United Nations International Law Commission and the role, so I can defer to the expert on that. But what I will say is that I think this is really important, because what I've seen, even though I've only been a few hours at this COP, is that we are speaking even more than ever before in echo chambers. There is the ocean dialogue, there's the cryosphere, there are the negotiators, which we haven't seen much yet, there are the side events. And I think unless we interlink this, we cannot even dream of interlinking international law text or international law and the science. So we heard in one event today, for example, that it is about time that we interlink the UNFCCC regime with the Convention on Biological Diversity, but that is not going to happen because we are all speaking in different spheres. We are not really talking the same language in many instances. So I think and I hope that this event can contribute towards a better understanding of what scientists are doing and how this science can be incorporated into the law, but also how the law can then inform the research that scientists do. Because I don't think this is a one-way road. It is really, it goes in both directions, and both disciplines have to inform one another. And that is also important because the science is negotiated, especially when it informs the IPCC with policymakers and lawmakers. Now, I've learned this at a very recent event that was organized by the UK government, a pre-scoping event for AR7. And there we heard that scientists sometimes find it quite difficult when they're convinced that this is the science that should go into the report, that this still has to be negotiated with parties, it has to agree to by everyone. So there is some or specific skill set needed to negotiate this science with policymakers. And I think this is a really important point, and I will in my own presentations come back to that and why I think that the science should have a self-standing role in addition to the IPCC for the Global Stocktake. But I think this is hopefully an event where we can at least start breaking up these echo chambers, and maybe when we go about these next days in COP, really try to attend and to go to events where we are not the experts, but we are nevertheless able to contribute something, but also certainly to learn something. So I really appreciate that you are here, and there are more coming now, which is absolutely wonderful. So thank you very much. And now with that, I will hand over to Chris Stokes.
Thanks, Petra. Yes, I'm just going to give a little bit of context behind the science of sea level rise, which hopefully then we can kind of pick up on in some of the discussion later as some of the presentation. So I'll be as brief as possible, but I think it's good just to look at some of the numbers and also look at some of the kind of variability in sea level rise that's going to be felt in different parts of the world. I mean, this cover image here is actually from the UK, not far from where I live, and you can see very clearly that sea level rise, it's not a problem that's going to happen in the future. This is something that's happening now that states with coasts are having to deal with now. So if we look at observed sea level rise, then actually over most of the last century, sea level rose at an average rate of around 1.6 millimeters per year. But actually, if you were to compare that to the last decade, you can see that it's increased to about 3.7 millimeters per year. And what this graph shows here is over the last 50 years or so, what has actually contributed to sea level rise. So you've got the observed sea level rise as the dashed line there. And then if you look at the different components, starting at the bottom in brown, you've got land water storage. That's kind of changes in the storage of water on land. So, if you take water that's underground, groundwater, and you extract it, you use it, and then it runs off into the ocean, that is actually having a contributory effect. Of course, building dams has the opposite effect and it stores. But at the moment, we know that actually depletion of groundwater is more dominant than retention from dam building. And then above that, you've got the contribution from Antarctica, Greenland, glaciers in grey, the small mountain glaciers and ice sheets. And then actually almost half of the increase in sea level is simply due to the thermal expansion of the ocean. And the largest component of that is this lighter coloured blue, which is the upper 700 meters. So a dominant proportion of sea level rise at the moment is simply from the thermal expansion of the ocean water as it expands, as it warms. But if you look at the last decade or so, and this is my final point here on the slide, melting of glaciers and ice sheets has now overtaken thermal expansion. And this is something that we're particularly worried about. If you look at thermal expansion alone, it's quite predictable how that might change with temperature change, whereas the contribution from melting glaciers and particularly ice sheets like Antarctica and Greenland, that's where we have some unpredictability. So that's what we're probably worried about as we think ahead to the future. And what this plot shows here is from the IPCC report, Chapter 9 of Working Group 1 in the last IPCC report. You can see the projections there with a relatively low projection and the high projection, which thankfully now is looking less likely. One of the interesting things is that if we look at kind of observations from the last few years, so where it says 2018, sea level has risen, and you can see the little squares there are giving you the different proportions of sea level rise up to that point. But it's clear from this plot that decisions that are made about temperature targets in the next few years, although we won't see the results of those in the next decade or so, there is a long-term commitment to what we do in the next few decades or so. We only start to see divergence between the different scenarios after about 2050. And so then, what we decide to do now about sticking to 1.5 or 2, or maybe going above 2, maybe looking at 3, that will have a big impact on what sea level rise will look like. And what tends to happen under high emission scenarios is that you get a greater proportion of sea level rise from the ice sheets in Greenland and Antarctica. I've also added this plot from the IPCC because it also shows in dotted lines what what they call low confidence projections are. And you can see there's a low confidence percentile, which is the dotted line, which actually takes you off the graph. Now, low confidence, 90%, that seems an extreme scenario. We might look at that number and think that's not going to happen, but that's a 1 in 20 chance of happening that we follow that dashed line. And that dashed line takes you up into several meters of sea level rise very quickly over the next few centuries. So this is really concerning. And it will be the ice sheets in Greenland and Antarctica that will start to contribute more and more of that sea level rise if we exceed 1.5 degrees. So what we would like to aim for is SSP1 1.9, where we peak, and then we come down to maybe 1.5 or below. And this is the same plot here. And the IPCC were very clear that projections in which Antarctica contributes much more than assessed ranges under sustained greenhouse gas emissions, that's 7 to 14 meters of sea level rise by 2300. It's unlikely, but they were unable to rule it out based on current understanding. One of the things I also like to point out, this is a plot to 2100. And again, we're looking at somewhere between half a meter to a meter. And if you look at the last few observations from the last few years, I should say, actually, we're tracking the upper end here of these projections. So we're probably looking at about a meter of sea level rise by 2100. But if you look at this bar on the right, this is 2300. even SSP1 2.6, which is a very ambitious target, that would be to see temperatures peaking at 1.8 and then slowly decreasing. Even that, we could get, and this is, reasonable percentiles, that will get over 3 meters by 2300, which is obviously catastrophic for coastal states. Now, I've been talking so far about global mean sea level rise, but we have to understand that sea level rise around the world is actually very uneven. So whilst the global mean sea level rise is 3.7 millimeters per year, the red areas here, due to gravitational effects, you actually see elevated sea level change in some parts of the world. That could be over 5 millimeters per year. And so that global average that I've been talking about very much masks what regional impacts you'll see. And it also actually depends on whether the ice that is lost comes from Greenland or it comes from Antarctica. That also has an effect on the redistribution of water around the planet. And those maps and also the numbers, they also don't say anything about the impact of storm surges, for example. So the more sophisticated models will try and factor those in for individual locations. So I guess the key point here is that you can't just use the global mean sea level rise. You have to be specifically referring to a certain part of the world. You have to bear in mind the frequency of storm surges. You have to bear in mind the gravitational effects. And you also have to bear in mind whether the land is subsiding or whether the land is uplifting due to tectonic forces and other factors that cause the land to rebound, such as from the last ice age. So we really need to be thinking about regional sea level rise. This is just an example here. This was a nice bit of work done, which said that actually, if you just think about ice that's being lost in Antarctica, it shows that AOSIS nations, the Alliance of Small Island States, will experience on average 11 to 33% higher sea levels. So these darker colours are where that water that's lost from Antarctica gets redistributed around the Earth. And I just thought I'd finish with a couple of visualizations of what this might look like. Globally, 230 million people live within a metre of sea level and 1 billion live within 10 metres. And it's been estimated from studies of the kind of economics of this that even 20 centimetres of sea level rise, we'd be looking at something like US $1 trillion to kind of, really, I guess these are losses. This is losses. This is not adaptation. This is losses from flooders if you don't put your defences in. This is obviously a part of the world close to where I live, but you can look at other parts of the world where things, again, most of these plots are 3 meters, and you can see here the areas in red will be the areas that will be inundated. And I've just got a few different examples. Here's obviously one based in Dubai, and you can see here that actually with 3 meters of sea level rise, we start to approach actually this venue in terms of sea level rise. Again, there are parts of Africa. So I just tried to quickly go around the world, South America. Obviously, lots of the world's major cities are in coastal areas. So just to conclude then, global mean sea level has increased by about 20 centimeters over the last century or so. And the average rate of sea level rise is accelerating now. This is something that we're really worried about. It's due to thermal expansion. It's also due to increased melting from the ice sheets in Greenland and Antarctica. And this is a point that I keep making in talks, that the science on the ice sheet contributions, the mountain glaciers, the thermal expansion components, they're actually quite predictable. Whereas the ice sheets in Greenland and Antarctica, they are much less predictable, much more complex systems. There's feedbacks in there that could lead to very rapid rates of sea level rise. And actually that science is evolving at timescales much shorter than the IPCC report. So we haven't got time to wait for the next IPCC report to see what the latest projections are going to be, because they're coming out now in papers where people are using more advanced models. They've got a better suite of observations to calibrate those models. And unfortunately, most of the new studies, in fact, the vast majority, are showing that things are actually going to get worse, or actually we're losing mass more quickly than we thought even just a few years ago. An example of that is that the combined ice sheet contribution to sea level rise is now 4 times higher than it was even just a couple of decades ago. So the conclusion, actually, from the ice sheets literature and the sea level literature, is that if we exceed 1.5, we're almost certainly going to trigger irreversible retreat of Greenland and the West Antarctic ice sheet that will commit several meters to sea level by 2300, so over the next few centuries. So that's what I wanted to say, and I'll now hand over to our other speakers to pick up some of the debate about this science. Thanks.
Okay. Well, thank you so much, dear Petra, and to the cryosphere team here for this invitation. And thank you for dear colleagues who are attending this evening as well. So I'm going to talk about the international law implications of the melting glaciers, Antarctica, warming ocean, and rising sea levels. Because sometimes the science may seem abstract to people, and yet we know that sea level rise will have is having, frankly, already direct consequences on people, on communities. And so from the legal perspective, international law perspective, there are various aspects to this that I'll go over very quickly as best I can. But to say this, much of international law, the treaties, for example, the Law of the Sea Convention, which I will address, but human rights, migration issues, all predate climate change. And now international law is facing the challenge of how to address this absolutely global planetary crisis. And sea level rise will impact all states, even landlocked, because of the consequences it will have on humans, from agriculture, water, migration, displacement of persons. Yet international law right now is really not prepared for this. So I'm a member of the International Law Commission. And the International Law Commission is a subsidiary organ of the General Assembly, and we are an expert body of international law experts. And so in 2018, the International Law Commission placed the topic of sea level rise in relation to international law on its agenda. And the reason was that actually the small island developing states, particularly Pacific Islands, were extremely vocal and proactive in raising the issue of sea level rise in the United Nations, and actually submitted a request, a written formal request that the International Law Commission take up this issue, and we did. And in doing so, we focused on three main issues, but that is not exhaustive of all the impacts that sea level rise will have. Law of the sea issues, human rights, and statehood. Because as you may or may not know, but as a result of sea level rise, by the end of this century, maybe even sooner, some of the very low-lying island states will disappear territorially. The question is, what happens to the legal status of statehood? So these are all really critical issues. But to focus now on the law of the sea issue, so the fact of the matter is that the existing legal structure for the law of the sea is based on maritime zones. And those maritime zones are constructed from something called a baseline. And the baseline is based on, in general, what's referred to as the low water line. But this was all before sea level rise. The maritime zones that we're talking about can, for example, in the case of small island states, can be 5 times more than their land territory. And this is particularly exclusive economic zone. And this is where fisheries, natural resources, they have exclusive sovereign rights over this area. The problem is, though, that sea level rise means that the coastal area will retreat. And if that coastal area retreats, the international law question is, well, what happens to the baseline? Does that now have to retreat as well? And if that retreats, does that mean that the maritime zones will change? Well, the changing of maritime zones is not just, okay, let's move this chair a foot over and just sit in a different place. No, it has many, many significant implications. One, it could result in the loss of valuable maritime space for coastal states. Second, once we start challenging the status quo, that can lead to conflict with neighbors. And maritime zones are an area of great conflict. They can take years and years to negotiate. And if because of sea level rise, these agreements or existing, sometimes they could be done unilaterally, can be challenged simply because of sea level rise. This then create what we call issues of conflict. And indeed, sea level rise was also taken up under the Security Council as a peace and security issue as well. So we're looking at these, and the way the International Law Commission works is that as experts, we do a report, we've been mapping the international law issues, and then states review this, the sixth committee, which is the legal committee of the General Assembly. And I have to say that since 2018, because of this interactive relationship we have with states directly, that we see a very strong trend. And the mantra is basically to ensure stability, legal certainty, and basically avoid conflict. The international law is clearly moving towards the idea of preserving existing rights. This also raises questions about statehood. And again, the presumption seems to be in international law moving towards the notion of the continuity of statehood regardless of sea level rise. But we still have many questions about what happens to the displacement of millions, maybe hundreds of millions or more of people, migration issues. And so we're also looking at that, the human rights issues, all because of sea level rise. So we at the International Law Commission are looking at this, and again, it's an important relationship with states we have, and hopefully finding to look legal solutions, at least within the framework of international law. But I have to say, as we see from the science, there's so much we can do as well. I think that I will end just by saying that we've been discussing this with Petra as well. I just saw the documentary about the last glaciers, and it is really powerful. And I think this message really has to get out to the public, what the implications are for their livelihoods. It's not just about the signs telling, okay, sea levels are rising, but how it impacts water. The fact that once those glaciers are gone, there's no water. I mean, a lot of the rivers will be impacted. Freshwater supplies, clean water supplies, agriculture. So rising sea levels is a multidimensional, multifaceted issue. And I think that it is so important. I was just thinking that that documentary should have been shown here. Maybe it is. It's so powerful, really, much more powerful than anything I could say. So anyway, that's basically the work we're doing in our capacity in the commission, 34 members, trying to bring some legal, practical solutions to a really monumental challenge brought by sea level rise because of climate change. So thank you very much.
Thank you very much, Chris and Niloufar, for two, I think, very powerful contributions here. Now, if I were a scientist, I would ask myself, why is everyone fretting about these decisions that come out of COP? Why does it matter whether they say urges or decides or requests or recommends? Why does this all matter? And also, I would be really disappointed when I see that on social media that somebody has already tweeted there won't be a new international treaty at this COP. So is this a reason for us to be severely disappointed? And it's not. So let me explain. I will make 3 points of how I think scientists can influence this lawmaking process that a COP always is, even if it doesn't come up with a new agreement. We won't see the Dubai agreement. It's not been planned. The Paris Agreement took years and years and years to negotiate. So we've heard already 2018 was a very important year when the ILC took a new and challenging topic on board with sea level rise, but it was also the year where it finished a really important project that had been on its agenda for several years. It also changed the names. It was very political. And that was about the subsequent agreement and the subsequent practice of states that interprets an international treaty. So these international treaties are never static. They are concluded, they have certain words in there, but they may not even be operationalized or cannot be implemented without further agreements. Or we see a certain form of practice arising under that treaty that interprets then how we have to understand certain provisions in that treaty. Now, in this lawmaking mechanism that these treaties, these multilateral treaties set forth for these COP decisions, and this is why they are relevant. Now, the ILC told us in 2018 that decisions that are taken by a conference of parties can have an interpretative value for the provisions of the treaty. It will depend on the wording, the clarity of the wording, and I'll be careful what I say here because we've got the expert in hitting distance, but so it's really important how it's being phrased. So I'm not saying all of them have the same legal value, but they can have a really strong hint on how do we have to interpret a certain provision. Now, why does that matter? What we have seen since COP26 is that there was, for the first time, really this urgency on the science, a special section even that says science and urgency. That was not further increased in Sharm el-Sheikh, but it was at least reiterated. So that is already twice that states have released a COP decision that interprets the Paris Agreement in a certain way. Now, under a very optimal scenario, we would have a decision perhaps coming out of this COP that says something along the lines, decides to place an additional emphasis on the science in relation to the cryosphere even. So the more concrete the wording, using the word decides will have a better interpretative effect for the law. And of course, the parties remain the authors of the treaty. So if they were going to reinterpret in a decision, and I'm not going to say that this is likely that this will happen, but they could, in theory, of course, say we are now focusing only on 1.5 instead of 2 degrees Celsius or well below 2 degrees Celsius, or even recognize that there is new science emerging that tells us that every increment and every fraction of an increment of a temperature increase even matters. So this is, of course, an area which not a single person can influence really easily, but I think by coming together and understanding these mechanisms, we make it at least more likely that we can work also with governments and negotiators to place an enhanced emphasis on the wording of these decisions. And I think hopefully this will give a different insight when we follow the negotiations during the final days, and when it becomes more and more important what the ministers will say at the end as well, to really focus and think about what these decisions will tell us in terms of legal interpretation. So that was my first point. The second point is closely related, another point where we could maybe use a legal lever to influence the system, and that is the Global Stocktake. Now, the Global Stocktake already allowed non-party stakeholders to make submissions. We could make submissions to all the phases of the technical assessment, go to the World Cafes, attend these meetings, make written submissions. And I'm really glad that with the ICCI, CIL, and Durham University, we've made a submission. But I think more is needed there to bring the academic research into this process. And the next Global Stocktake, even though it may be 5 years away from now on, it will start earlier because the Global Stocktake that now comes to a close has also taken over 2 years. So it's time to get the papers published and ready, and then submit also again to this Global Stocktake and to this process. And there could also again be a decision, of course, that decides coming out of this COP that we are not going to wait until another 5 years are over. Maybe there is an interim process that has been in the discussions. We will see where that goes. So the Global Stocktake is really important. It's also important to remember that they even though they are looking at the IPCC science, there's also science that comes out after the IPCC may have concluded. So there's, as we've heard, always emerging science, and it's really important to take the latest science into account, because that is something that parties have endorsed in the Paris Agreement. They've not said we're looking into that has been published 3 years ago. So really taking that seriously and demanding that there are entrance points for the latest published science. That is the second relevant point for influencing this lawmaking process, political decision-making process at times. Now, the third is to looking really closely into trying to understand some of the mechanisms, and the Global Stocktake is already one, that the Paris Agreement sets forth. There's another one that is really critical, and you will have heard a lot about it already on the Article 6 agenda. Now, Article 6 sets forth 2 different paragraphs with market-based instruments. Article 6.2, voluntary approaches. Article 6.4, the Sustainable Development Mechanism. Both of these have certain criteria that lawyers on their own, politicians on their own, no one can fill on their own. We need to bring again the interdisciplinary research into that, and the science will be really relevant. And I can briefly explain why. So these voluntary approaches are a way of unlocking largely private investment into certain projects that will lead to the reduction of carbon emissions, so mitigation outcomes. And these mitigation outcomes can then be traded. These are then internationally traded mitigation outcomes. This is something that is different from the voluntary carbon market, because the voluntary carbon market is exactly that, voluntary. Whereas now we've got parties that have targets, NDCs, and they want to meet these targets. In order to meet these targets, they can use this Article 6.2 mechanism. So it's a great opportunity, but it's also a great risk, because it can go really wrong, as you can imagine. Now, there are certain legal criteria attached to trading these called ITMOs under Article 6.2. And these are to some extent defined. An ITMO must be real, verified, and additional. So it must be from a project that otherwise would not have occurred. And it must also be environmentally sound, and it must be accounted for. So if, for example, party A invests in a project, let's say, for example, replacing diesel buses with e-buses in country B, then there will be emission reductions in country B. These emission reductions go back to the NDC calculation of country A. So in that country, the emission reductions will be accounted for, but not in the other country that has actually experienced them. So we are, in that sense, circumventing the territorial accounting for emissions. Yes, so we are accounting for emission reduction in the other country and transferring it. There are huge risks with that, because, of course, both countries will have an NDC. So there is an incentive in that sense to do this accounting twice. But the Paris Agreement clearly states there can't be double counting. There must be a corresponding adjustment. So country B must treat these e-buses as diesel buses still. Yes, so no additional emission reductions can be taken into account for the NDC of country B. So this corresponding adjustment is one big mechanism that needs to be aligned, that needs to be understood, and where also there needs to be, of course, some reporting for parties and some scrutiny applied to it. What is the entrance point for the science? Now, I think environmental integrity is the obvious one, because, again, these ITMOs need to be environmentally sound. How do we understand what that is? And I think here case studies can be really important. And if we have a case study like the cryosphere, the ice sheets, the fragility of the ice sheets, what's happening underneath the ice sheets, what are these tipping points from where we can't really influence anything any longer, and so on. I think this is really important to have parameters for environmental integrity, because there is a strong climate signal from these cases, so that we know in these areas, if we have a certain investment that then doesn't meet this threshold, for example, because it leads to further emissions, for example, or it doesn't reduce them as much, then it won't be one that is in line with these criteria that Article 6 envisages. So I think it's really important to work together on these mechanisms that we have in this international treaty. So with that, I will at this point conclude, and thank you very much for your attention. And I think we would be all still happy maybe for 10 minutes or so if there are any questions here in the room. Very happy to answer them for the entire panel, of course. Thank you all very much for your attention.
What question? Maritime baselines. So, yeah, so I guess they must move quite a lot from like natural deposition of silt. There's a lot, but also countries physically build out islands and stuff in the South China Sea and elsewhere. So there must be like a template to move these baselines historically. Have they moved ever? What happens to that when China builds an island? What happens to the baseline?
So you're scientists. That is a very, very good question. So in this case, what we're looking at specifically is baselines that could move, not necessarily do, because baselines don't really exist in the sense it's illegal drawing. But due to sea level rise, the existing baseline, which would be our base points, offshore fugitives. The reality is, in practice, many states do not actually resurvey their coastline. Very few do. The ones that do are usually the ones that can afford to do it. It's quite costly and expensive. So the practice is really not doing it. This is the South China Sea. International law is very clear. You cannot, through artificial means, create from, for example, low tide elevation an island. And I won't go into details because an island that can sustain human habitation and an economic life of its own, this is legal jargon, gets all those maritime entitlements, but it has to be a naturally formed island. You can preserve such an island through artificial means. So, and for example, Singapore, where I come from, yeah, they do a lot of expansion, and their colleagues from Indonesia as well here. Through that, and their baselines haven't been. But the requirement to change your baseline, that under international law, actually, there is no state practice for that. There's no codification for that. So that's why in the General Assembly, we're seeing increasingly the acceptance that, okay, it's sea level rise due to climate change, but the scientists may have to tell us. They say, can you actually distinguish that? But we're not going into that level of detail. That will not be challenged.
Thanks.
But thank you for your question.
So thank you. You mentioned the impact of sea level rise, like migration, security. It's already been there before, like it's being dealt by different bodies, for example. So I was wondering, do you think the UNFCCC is the best institution to deal with these issues, and how do you think the UNFCCC can deal with these issues?
The UNFCCC, well, I'm not sure it's the best place to deal with it, to be quite honest. And it is being examined in different fora. You have that for Human Rights Council, the Human Rights Committee, where there's some cases that come before them. So I think the UNFCCC, it isn't really a human rights body. It only recently in the preamble reference to human rights. But it can be referred to. I think the COP decisions that I was talking about, they're really an acknowledgement of the importance that, we have to look at the UN system as a singular system, not, and this is something we talked about earlier, not this fragmented silo, well, this is my area, that's your area. Certainly UNFCCC has a role to play, but is it the ideal place? No.
there is a question. I think maybe the NDC could be a more pronounced reminder for parties to think about health. So yeah, that would be something human health. And we'll probably, hopefully, after this talk, we will see play a bigger role in these things.
No, I mean, I asked because it's usually discussed under lots of language and there's still
Yeah,
concept and it hasn't really moved. Give me that.
No, it's why these are people may not be
yeah,
insufficient.
it's not.
What do you think is the most effective way to include science that isn't included in the IPCC?
Into the Global Stocktake, I think, really making these submissions. And there's sometimes calls, so if your institution is an observer, there's sometimes calls for submissions to specific questions even. So it could be on adaptation, could be on loss and damage. And just looking out for these calls and making a written submission. Yeah.
I would say most scientists don't understand the legal implications of those words. Adaptation and mitigation, most scientists don't mean a legal process. So what do you think is the best way for the COP to help reach out and include scientists within that process as well? Because
I think I'm not sure the COP or the UNFCCC Secretariat even will give this assistance, because they're not going to send out a performer and then you fill that in and then there's the evidence. It's very much driven by those people who are making the submissions. I think this is a great place to start these interdisciplinary conversations and then taking them forward and really building these groups where you work together on this language and to make sure that there isn't an unwanted outcome, because sometimes the language can also be so ambiguous that it's even counterproductive. So I think it's quite important to work together to understand what these words mean, and then to understand the science and bring these two beliefs together, as we're trying to do in our Center for Sustainable Development Law and Policy as well in Durham University. And it takes a lot of effort. I think this real interdisciplinarity is not each writing 10 pages. It's finding this joint language and realizing that we are speaking different on different levels sometimes even. So yeah, but it's very important.
I guess one of the advantages of COP as well is that scientists can get to speak to policymakers directly, so that they're not necessarily relying on the IPCC report. We've had instances where heads of state even have visited with Australia, Trillium, etc. So you can get that message across directly to them, which everything else is speaking IPCC is indirect. The other thing that brought to mind in the question is the technical dialogue as well. The SB58 that takes place in Bonn. There was a specific price-fair workshop, which had the aim of getting the latest science to negotiators who could then take it into the IPCC process.
thank you.
Thanks for the talks. I'm just thinking, in terms of the focus on it's Greenland and the West Antarctic ice sheet, but then you're also hearing a lot about other areas of the Arctic, aren't we? We're opening up this passage possibly across northern Canada and stuff like that. And I'm just looking at this chart up on the wall here in different settlements and how many people are settled into permafrost kind of areas. And I just wondered, well, for example, what about the whole situation with Russia at the moment, which isn't really party to any of these kind of discussions anymore, and yet they've probably got the most people affected by is that a big issue, or is there still work going on in the scientific community?
I think there's several themes to the Cryosphere Pavilion, all of which essentially boil down to loss and damage. When looking at the impact of climate change, so permafrost is one particular theme, which has a very direct impact on the people that there's the chart. Who live on permafrost, who rely on permafrost, in some sense, I've heard it said, you know, in terms of human rights, they have a right to be cold. It's played sometimes. But the other themes, you know, like we're just talking about sea level rise. The other mentioned that, you know, when mountain glaciers disappear, you lose that water resource. And somebody commented, I think there's 2 billion people interact with glacial meltwater. And when that meltwater is gone, you don't have that resource. Sea ice we've talked about as well, and the role that plays in kind of climate change and feedbacks involved there, and the impacts on the ocean system, and the impacts on fisheries and aquaculture. So I think one of the messages that the Christ Pavilion tries to get across is that these are not problems that are going to be restricted, you know, to areas of the world with ice components, but actually that there are knock-on effects. You know, sea level rise, I was very much focused on the coastal states, but as it's being pointed out, once you start having to move, it will easily impact on the states without the coast as well. And I would say in response to that, in the last one, especially science is very simple on this. There's no question here. There's one or two things, you know, of course, there's complexity that we don't understand, but in terms of taking action, all of those different components, whether it's permafrost, mountain masses, the big ice sheets, the sea ice, the polar oceans, all of the sciences that, you know, the lower you can keep the temperature, the less the loss and damage will be. As I said in front of the state question, what you can't negotiate with melting point of ice, you know, it's a few times, but it's a very simple physical response.
Thank you very much. I think that's a really good point to every time you can't negotiate with the melting point of iron. I think that's given that gets it early in these days. So hopefully that will be listened to widely. Well, thank you all again very much for being here at this relatively late time, and thank you also very much for the speakers here. Thank you.
Let's leave it.